Imagine a night so deep, so vast, that even light hesitates to cross it. Out there, beyond the glittering rivers of stars, something sleeps, something that bends the very fabric of reality around itself. A silence older than galaxies. A hunger so patient it could wait 1 billion years. Tonight, that silence stirs. Hey there, and welcome to Science for Sleep. I'm so glad you found your way here. Maybe it's been a long day. Maybe your mind just needs a quiet space to wander for a while. Either way, this is your time, your soft, unhurried journey through the mysteries of the universe. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you'd like, share where you're listening from tonight, your city, your local time, maybe even what the sky looks like outside your window. Now, if you're ready, let's begin. Out in the dark, black holes sleep. They do not move in any way we can see, do not shine, do not speak. They simply wait. Each one, a ghost of a star that once burned fiercely, a giant that lived and died in fire. When that star's fuel ran out, gravity took control. The light fell inward, the matter collapsed, and a new kind of object was born. One so dense, so curved, that space and time themselves could not escape its pull. It is strange, isn't it, to think of darkness as something alive. We imagine it as emptiness, a hollow absence. But in truth, a black hole is not empty at all. It is overflowing with gravity, with energy, with the invisible weight of everything it has ever devoured. Like a heart between beats, it pauses, quiet, waiting for its next pulse of light. When a black hole begins to feed, the stillness shatters. From the outside, you might not see the black hole itself. That part remains hidden behind its event horizon, the point of no return, but you will see its hunger. You'll see the storm it creates in the matter around it. Gas, dust, even entire stars spiral inward, caught in an invisible whirlpool of space-time. Imagine the scene. A cloud of gas drifts too close. Slowly, irresistibly, it begins to fall. The closer it gets, the faster it moves, drawn forward by gravity's whisper. At first, there is only silence then, friction, heat, light. The falling matter glows, hotter and hotter, until it outshines the combined light of millions of suns. From a distance, it looks like a halo, a golden ring burning around a dark center, the edge of a cosmic eye staring into forever. And inside that ring, something stirs the hungry heart of the cosmos, awakening. Astronomers call this ring an accretion disk, a word that feels almost too small for what it describes. It is a storm of pure energy, a slow-motion catastrophe that lasts for thousands of years. Each particle in that disk spins faster and faster, colliding with its neighbors, heating to unimaginable temperatures. Friction tears them apart. The atoms glow in X-rays, in ultraviolet, in light invisible to human eyes. If you could stand near it, though of course you never could, the radiance would vaporize you before a thought could form. Yet here, in the quiet of imagination, you can watch safely. You can drift closer in your mind. The disk rotates, shimmering like molten gold. The space around it warps, bending light into graceful arcs. The stars behind it twist into crescents, their images stretched and folded by gravity's curve. You are watching space-time behave like liquid glass, rippling under the weight of its own rules. Somewhere within that chaos, the black hole itself remains unseen, a sphere of absolute night, smaller than a city, but heavier than entire solar systems. Nothing escapes it. Not light, not sound, not time. And yet, in this feeding, it becomes the brightest thing in the universe. Darkness becomes light, and consumption becomes creation. Scientists once feared black holes were purely destructive, that they were cosmic drains swallowing everything in reach. But in the past few decades, we've learned something gentler, something almost poetic. When a black hole feeds, it also gives back. The heat and radiation from that accretion disk ripple outward, influencing the birth of new stars. The outflows of energy sculpt galaxies, shaping their arms, their rhythm, their balance. You could say that black holes are gardeners as much as they are predators, pruning, guiding, maintaining. Without them, the cosmos would be quieter, yes, but also emptier. Their hunger is part of a larger harmony. When you think of it that way, feeding is not destruction. It is transformation. The idea that a black hole could awaken, that something so silent could suddenly roar to life, stirs something in us too. Maybe it reminds you of your own cycles, the times when you felt dormant, still, unseen, and then, suddenly, something within you reignites, a purpose, a curiosity, a need to reach again toward the unknown. The universe is full of rhythms, like that long sleeps, followed by brief moments of brilliance. Stars are born, burn, collapse, and give rise to new light. Even galaxies drift together and apart like slow, eternal breaths. The feeding of a black hole is just another kind of heartbeat in the vast body of the cosmos. So as you listen now, maybe you can let that rhythm guide your breathing. Inhale slowly, exhale softly. Imagine the gravity pulling everything toward its center: thoughts, worries, stray memories, all spiraling inward, dissolving in warmth and quiet. Because here, in this story, you don't have to do anything. You don't have to resist or analyze. You can simply fall, gently, into the calm pull of curiosity. And as we drift deeper into the series tonight, we'll follow these cosmic hearts as they awaken, feed, and shape the stars around them. We'll watch light bend, time stretch, and reality itself begin to waver at the edge of the event horizon. But for now, just breathe. Let your mind float like dust in the soft gravity of wonder. Somewhere out there, a black hole has begun to feed. And in its awakening, the universe glows a little brighter. Sleep well, traveler. The cosmos is still watching, still dreaming, and so are you. Imagine a galaxy seen from afar, a spiral of light, slowly turning through deep space, its arms brushed with stars like luminous paint. At the very heart of that quiet motion lies something invisible, a weight that does not shine, a silence that anchors everything else. That silence is a black hole, and most of the time, it sleeps. For billions of years, many black holes drift through space like ghosts, wrapped in darkness, undisturbed. They are not always devouring. They are not always blazing with light. In truth, most are calm, so still that you could pass within a few light years and never know they were there. They wait in the centers of galaxies, or wander between them, the remains of once brilliant stars that burned out long ago. It's strange to think of something so powerful choosing quiet. These black holes, these sleeping giants, are more massive than millions of suns, yet they hide their strength with perfect patience. They remind us that even the mightiest forces in the universe spend most of their existence at rest. They do not chase, they simply wait. A sleeping black hole does not glow. It does not radiate energy into the cosmos. It simply bends the light that passes near it. Astronomers detect these hidden giants, not by sight, but by absence by the way. Stars orbit an invisible point, by the way light from behind it curves and magnifies, by faint gravitational murmurs recorded across the sky. Our own Milky Way has one such sleeper. Its name is Sagittarius A*, a supermassive black hole, about 4 million times heavier than the Sunday. For now, it slumbers. Around it, stars whirl in quiet orbits, moving at immense speeds, yet never colliding. Once in a while, a puff of gas drifts too close, lighting up the dark for a few hours or days, a brief spark before silence returns. Astronomers call these flashes, flares, as if the galaxy itself were blinking, remembering its heart for a moment. Imagine watching it from a safe distance, perhaps aboard some dreamlike observatory floating high above the galactic plane. You see nothing at first, only the faint glow of starlight and the swirling clouds of dust. Then, suddenly, a spark, a burst of golden light spiraling inward, fading just as quickly. It is the heartbeat of a sleeping god, one pulse every few centuries. Every black hole has its own story of origin. Some were born in the depths of massive stars, collapsing under their own gravity. Others, the ancient ones, may have formed when the universe itself was young seeds of darkness that grew as galaxies gathered around them. Over eons, they consumed gas, merged with others, and shaped the grand structures of the cosmos. Yet, even with such power, they rest more often than they rage. Feeding takes fuel, and space is mostly empty. The average black hole spends the majority of its time surrounded by nothing, drifting in an endless sea of cold radiation and thin gas. When matter finally comes near, it is like rain falling on desert sand. For a brief while, it drinks deeply, shining brighter than 1,000,000,000,000 stars, and then the desert returns. You can think of it like the tide-long, slow cycles of hunger and calm. The feeding frenzies may last millions of years, but the silences stretch longer still. Between meals, the giants sleep, cooling and darkening until even their memory fades. If galaxies were living beings, black holes would be their hearts, beating once every cosmic lifetime. Scientists sometimes call these dormant black holes quiescent. The word itself feels gentle, doesn't it? Quiet, resting, at peace. And yet, within that peace lies incredible tension, like a bow pulled back, but not yet released. Inside every quiescent black hole, the laws of physics are still twisted beyond recognition. Space is still curved infinitely inward. Time still slows to a crawl, but nothing disturbs it, not yet. If you could somehow hover near one, you'd see nothing, just a patch of sky where stars seem to vanish as their light bends away. You'd feel no pull until it was too late. The gravity doesn't announce itself. It whispers. Even when asleep, these giants hold entire solar systems captive, sculpting the motion of planets and gas clouds with invisible hands. Sometimes, a black hole's sleep is disturbed not by a star, but by another black hole. When two galaxies merge, their central giants begin a slow dance. For millions of years, they spiral closer, sending ripples of gravity through space waves that stretch and compress the very fabric of reality. Eventually, they meet, fusing into a single, larger being. And then, once again, silence. One heartbeat ends, another begins. There is something almost comforting in their patience. Humans measure time in hours, days, years. Black holes measure it in aeons. They do not hurry. They teach us that stillness can hold power, that waiting is not always emptiness. When astronomers map the universe, they find these quiet anchors everywhere. Nearly every large galaxy has one. Some hold the equivalent mass of millions of suns, others billions. Together they create a hidden network of gravity, binding galaxies into clusters, clusters into filaments, filaments into the great cosmic web. Through them, the universe holds its shape, its luminous pattern suspended around centers of perfect darkness. Without black holes, galaxies might drift apart, their stars scattered into nothing. With them, the universe maintains balance. The sleepers keep watch, unseen but essential, like the deep bass note beneath a cosmic symphony. So, as you listen now, imagine those sleeping giants scattered across the sky. Picture them resting quietly at the hearts of distant galaxies, invisible but present, like embers buried under cosmic ash. Some will awaken again, someday. A wandering star will pass too close. A cloud of gas will fall inward, and for a little while, the dark will glow. But not tonight. Tonight, they sleep heavy, patient, eternal. The galaxies spin above them like lullabies, and the cold breath of space hums softly through the void. Perhaps, in their slumber, they dream of light. Out there, in the endless dark between the stars, hunger awakens. A black hole that has slept for centuries senses motion, a faint disturbance at the edge of its gravity well. Something approaches. A star, brilliant and unaware, has wandered too close to a place where the rules of space begin to twist. At first, nothing seems wrong. The star continues its orbit through the quiet void. But gravity, patient and invisible, begins its pull. Each hour, the attraction grows stronger. The star elongates almost imperceptibly, its perfect roundness stretched like soft glass. The closer it drifts, the more that gentle pull becomes a cosmic grip. The star has crossed the point of no return, and the black hole begins to feed. This is the moment astronomers call a tidal disruption event. It sounds clinical, almost calm, but in truth, it is one of the most violent scenes in the universe. The name comes from the same force that moves the tides on Earth, the pull of gravity across distance. The black hole's gravity tugs harder on the star's near side than its far side, creating a difference so vast that the star cannot hold itself together. Imagine it. A sphere of light stretching into an oval, then into a stream, its gases torn apart atom by atom. The star's outer layers unravel like silk in a storm. The process is slow by human standards, but in cosmic time, it happens in a heartbeat. The black hole does not devour it in one bite. It savors it, pulling the star into a graceful spiral, wrapping its remains into a luminous ribbon of plasma. Half of that glowing material will fall inward, joining the accretion disk, the bright, swirling ring of matter that forms around the event horizon. The rest will be flung outward, into space, forming arcs of gas that drift away, still hot, still glowing. From a telescope, it looks like a sudden flare. A galaxy that was quiet for ages now burns with new light, as if reborn. If you were floating far away, safe in some quiet corner of the galaxy, you'd see it as a flicker, a slow pulse of radiance against the velvet dark. The light would travel for millions of years before reaching your eyes, telling the story of that single star's end. But if you could move closer, you'd see motion beyond imagination. The stream of stellar matter twists into a spiral that wraps tighter and tighter. Friction turns energy into heat. Magnetic fields writhe and snap. The gas glows in shades of blue and gold, X-rays flickering through the void. And at the center, invisible yet all-powerful, the black hole drinks. You might imagine it as greed, as destruction. But in truth, it is balance, the oldest rhythm in the universe. Creation, collapse, rebirth. The death of one star feeds the birth of others. The energy released in this feeding floods the surrounding space, stirring new clouds of gas, igniting distant nebulae into life. Every end becomes a beginning. In slow motion, the accretion disk forms. Its inner edge spins near the speed of light, while the outer edge moves more gently. This difference in speed twists the gas into immense whirlpools. The heat soars to millions of degrees. The disk becomes so hot that it emits light across the entire spectrum, from visible colors to X-rays that no human eye can ever see. The light flickers, dimming and brightening like a heartbeat. Each pulse reveals something about the black hole's appetite: how fast it spins, how massive it is, how much matter it consumes with every turn. Astronomers record these pulses and translate them into data, the language of gravity itself. But there is something deeper beyond the science, something almost musical. The feeding black hole hums, not in sound, but in vibration, gravitational waves, rippling outward, distorting space-time itself. It is the universe's quiet song of hunger, a symphony written in curvature and light. It's easy to think of the star as lost, devoured, destroyed, but in a strange way, it becomes eternal. The photons released from its fall will travel forever, racing across galaxies, brushing past worlds that will never know their origin. Some of that light may fall on a planet where someone, someday, will raise a telescope and wonder about the source of that glow. In that moment, the star's story will continue, a flicker of memory carried by light. We tend to imagine black holes as symbols of annihilation, but they are also storytellers. They preserve the memory of what they consume, translating it into energy, into motion, into gravitational ripples that echo through time. As you listen now, imagine drifting closer. You are watching the star's final dance, a river of fire flowing toward the dark. The black hole's gravity bends space so completely that the light of the falling matter curves around it, forming a glowing ring that circles endlessly. At the center is nothing visible, only an absence. But that absence is full of the star's last energy, its last heat, its final act. The black hole shines not with its own light, but with the brilliance of what it consumes. There is beauty here, even in destruction. The same beauty you see when a fire burns bright before fading, when the ocean swallows the setting sun, when life gives itself back to the world so others may grow. In time, the flare fades, the disk cools. The black hole returns to its slumber, larger now, heavier, its hunger briefly satisfied. The space around it grows quiet again. The light that once blazed across the galaxy drifts outward, thinning into the endless dark. The feast is over, but its echo will travel forever, whispering through time, a story of gravity, of hunger, of the moment when darkness turned to light. So take a slow breath, let it out gently. The universe feeds, and so does your mind, on wonder, on calm, on curiosity. Somewhere, a star has fallen, and the cosmos is at peace again. Far away from any world, in the deep silence between galaxies, there is a sight both haunting and hypnotic. A circle of light surrounding a center of absolute darkness. It is one of the rarest and most beautiful sights in the universe. The glowing halo of a black hole as it feeds, called an accretion disk. To the human eye, it would seem like something out of a dream. Imagine a sphere of pure night, framed by a luminous ring that never fades. The light swirls endlessly, shimmering like molten gold. But it does not come from the black hole itself. It is the light of everything that is falling in gas, dust, the ashes of stars heated to unimaginable temperatures as gravity pulls them toward their end. This is where the universe becomes paradoxical. The darkest object produces the brightest light. When matter spirals toward a black hole, it does not fall straight in. It circles, again and again, trapped by the powerful spin of space-time itself. Friction between the particles creates heat, and the heat becomes radiation, the same process that makes a star shine, but magnified to extremes beyond comprehension. The inner edge of the disk whirls at nearly the speed of light. The outer layers drift more slowly, creating vast shearing currents of plasma. The temperature climbs into the millions of degrees, and the disk begins to blaze. To distant observers, it becomes visible across cosmic distances, a beacon that marks the location of an otherwise invisible being. Through telescopes tuned to X-rays and gamma rays, astronomers can see these disks as glowing halos, flickering like cosmic lanterns in the dark. They call such objects active galactic nuclei, or quasars. Some are so bright They outshine the galaxies that contain them, pouring out the energy of 1 trillion suns, all from a region smaller than our solar system. If you could approach one safely, if you could drift through the cold vacuum until the black hole filled the sky, you would see something unlike anything else in existence. The light from the far side of the disk would bend around the black hole, curving back toward your eyes. Every ray of light would follow the shape of gravity, wrapping the void in a luminous ring. This phenomenon is called gravitational lensing. It means that even though the black hole itself is invisible, its presence reshapes everything we see. Light bends where it should travel straight. Time slows where it should flow evenly. The universe itself becomes a mirror, and you are watching space fold upon itself. The result is an image that feels impossible. A black circle surrounded by a halo of fire, its edges distorted like ripples on water. The center is not just dark, it is the absence of all return, the event horizon where light disappears forever. Around it, reality stretches to its limits. In April of 2019, humanity saw such a ring for the first time. The Event Horizon Telescope, a network of radio observatories spanning the Earth, captured the image of the supermassive black hole in galaxy M87, a giant 55 million light-years away. What they saw confirmed decades of theory. A glowing ring, almost perfect. Its brightness uneven because the disk spins at nearly the speed of light. That photograph, blurry, glowing, golden, was more than an image. It was a glimpse into a place where our understanding of physics begins to blur. It showed us that even in the most extreme darkness, light persists, bending and twisting in obedience to unseen rules. It showed us that beauty exists even where nothing should exist at all. The light around a black hole tells us a story not of destruction, but of transformation. Every photon escaping the disk carries with it a fragment of what once was. The atoms of a star, the dust of a world, the debris of an ancient collision. Each one leaves just before it would be lost forever, like a whisper escaping a mouth that will never speak again. And what escapes is breathtaking ribbons of color stretched across the electromagnetic spectrum. To human eyes, it might shimmer gold and white, but in truth, it glows in every wavelength imaginable. Radio waves hum from the outer disk. X-rays pulse from the inner edge. Together, they create a cosmic harmony, a spectrum born of chaos, light emerging from collapse. Even the shadows here are beautiful. Near the event horizon, the black hole's gravity traps light in orbits. These photons circle endlessly before vanishing, forming a photon ring, a razor-thin edge where light skims the surface of eternity. It is here, at this threshold, that the universe's rules begin to falter. Time slows, space folds inward, every second stretches toward infinity. If you could watch this scene from afar, you'd see the same instant repeated forever. The light leaving that ring now may continue for billions of years before fading into the cold. For astronomers, studying these luminous rings is like reading the diary of gravity itself. Every flicker in the disk reveals something about the black hole's spin, mass, and magnetic field. The brightness tells them how fast it's feeding, how hungry it remains. Even the shape of the ring reveals whether the black hole is twisting space-time around it like a whirlpool. And yet, beyond all that data, there's something almost spiritual about it. A circle of fire around a hole in existence, an infinite silence bordered by light. A reminder that what we call destruction is often just another form of creation. So as you listen now, picture that ring floating in the vastness. Picture the slow dance of light as it curves around the dark heart at its center. The stars around it shimmer faintly, as if paying homage to the gravity that binds them all. The void is never truly empty. It is full of movement, of memory, of energy, waiting to become something new. Close your eyes Let that image form in your mind, a glowing halo in endless darkness. You don't need to understand every detail. You only need to feel its quiet rhythm, its eternal pull inward. The same force that shapes galaxies is here too, inside you, drawing your thoughts towards stillness, guiding your mind toward peace. Because the universe doesn't just collapse, it shines as it falls. And somewhere, even now, another ring of light is forming around nothing at all. There is a music in the cosmos, though not in any form the ear could ever hear. It hums in the silent language of motion and light, the deep, vibrating song of matter falling toward a black hole. Every particle, every photon, every ripple of radiation adds its note to the grand symphony of gravity. When a black hole feeds, the universe listens. The gas and dust that spiral inward do not simply vanish, they move in rhythm, creating waves of heat, bursts of light, and pulses of energy that ripple through space. From a distance, we can measure those rhythms, turning invisible patterns into sound. Scientists have actually converted the fluctuations of X-rays and radio waves around black holes into audio frequencies. The result? A deep, droning tone lower than any human instrument, slower than any heartbeat, echoing across millions of light years. Imagine that. A song older than time, sung by gravity itself. The process begins with chaos. Clouds of gas fall inward, colliding and compressing. Friction between the particles heats them to extraordinary temperatures, millions of degrees, until they radiate in X-rays. As the matter draws closer, it begins to form structures like spiral arms, shock waves, and magnetic filaments. These are the instruments of the cosmic orchestra. The outer regions play softly, long, slow waves of radio and infrared light. The middle regions hum in visible and ultraviolet tones, and the inner edge, that furious, spinning ring where space bends most, screams in X-rays and gamma rays. Each band of energy contributes to a spectrum that fills the universe, a harmony of destruction and rebirth. Yet, despite the violence, there is grace. The orbits align, the flows synchronize. Gravity turns chaos into order, a dark symphony conducted by silence. In laboratories and observatories across the world, scientists watch this performance unfold. Radio telescopes pick up the faint hum of plasma jets shooting from galactic centers. Space-based X-ray detectors capture the bursts of energy from matter colliding at nearly the speed of light. Each signal is a note, each flare a crescendo, each flicker a pause between phrases. What they see is astonishing. Black holes, the ultimate absorbers, are also astonishingly expressive. When they eat, they sing. The light they emit flickers rhythmically, producing what astrophysicists call quasi-periodic oscillations, a gentle pulsing that repeats in time, like the breath of the cosmos. Some of these beats are seconds long. Others take hours or even days. They reveal how matter behaves under gravity's most extreme control, and perhaps how the universe itself keeps time. If you could drift near a feeding black hole safely, impossibly you would not hear sound in the traditional sense. There is no air, no medium for vibrations, but you would see rhythm. The flickering light from the accretion disk would shimmer in steady pulses, as though the black hole were breathing. The radiation would pulse through your instruments in patterns so regular they could be mistaken for a heartbeat. In a way, they are heartbeats, the heartbeats of the cosmos, measured not in seconds, but in gravitational beats, the rise and fall of space-time itself. It's mesmerizing to think that what looks like chaos from afar is actually ordered motion, an elegant choreography of energy. The gas that falls inward loses its individuality, merging into a single spiraling flow. Each atom, once part of a star, becomes part of a greater rhythm, a single movement in a cosmic composition. Every black hole has its own song, Small stellar mass black holes, the remnants of dead stars, hum at higher frequencies, their disks spinning quickly, emitting sharp bursts of light. Supermassive black holes, those that sit in galactic centers, vibrate more slowly, their deep tones resonating across light years. If we could somehow translate their songs into audible form, the smallest black holes would sound like quick violins, while the largest would rumble like slow, distant drums. Together, they would fill the universe with a background hum, the gravitational chorus of billions of dark hearts beating in unison. This background hum is not a metaphor. In 2023, astronomers using pulsar timing arrays detected hints of a gravitational wave background, a faint, persistent vibration stretching across the universe. It may come from merging black holes or from the oscillations of space itself. It's the cosmic baseline to everything that exists, vibrating through every atom of your body right now. The deeper you go into this idea, the more it feels alive. The universe is not silent, it merely sings in wavelengths too slow for us to hear. The same waves that flow from black holes pass through Earth, through you, through your heartbeat. Somewhere, billions of light years away, two black holes may be merging, and the faintest echo of that collision is trembling invisibly in the atoms of your skin. It's humbling and comforting to realize that even in stillness, we are part of a living, vibrating cosmos. When you breathe, when your heart beats, when your mind drifts towards sleep, you are resonating with the same patterns that shape galaxies. You are, in some quiet sense, participating in the universe's music. So, as you lie back and listen to this story, imagine the soundless song of falling matter, a deep, steady rhythm echoing through eternity. Imagine gas clouds spiraling inward, like dancers moving to a tempo older than light itself. Imagine the flare of energy that bursts, fades, and begins again, like a soft melody that never truly ends. The universe is not cruel in its hunger. It is patient, creative, and endlessly rhythmic. Every fall becomes a song. Every collapse becomes light, and somewhere, in the dark heart of a distant galaxy, a new verse begins, another black hole feeding, another pulse of brightness, another note in the infinite symphony of creation. So breathe softly, let your heartbeat slow. The cosmos is singing tonight, and for a little while you can listen. Gravity does not only pull, it twists. Near certain black holes, the very fabric of space begins to swirl like water circling a drain. This is not a figure of speech. It is literal motion, written into the geometry of reality. These are Kerr black holes, named after the mathematician Roy Kerr, who first described them in 1963. Unlike static black holes, they spin sometimes at almost the speed of light. Their rotation drags the universe itself into motion around them. It's a phenomenon called frame dragging, and it's one of the strangest, most elegant ideas in modern physics. Imagine space-time as a soft fabric stretched across the cosmos. Now picture a spinning sphere pressed into that fabric. As it turns, the surface doesn't just dip, it pulls the surrounding material into rotation. Near a spinning black hole, space behaves the same way. Anything nearby, gas, dust, light, even time itself, is forced to rotate. The universe, for a moment, forgets how to stand still. If you could hover safely near one of these giants, you'd see the effect with your own eyes. Light from distant stars would twist into spirals as it passed by, like paint drawn into a vortex. Even if you tried to remain motionless, you couldn't. You'd be caught in the current of space-time, pulled into rotation whether you wanted to or not. Astronomers call this region the ergosphere, the outer layer of the black hole's influence, just beyond the event horizon. The ergosphere is a boundary between stillness and spin, between calm and irresistible motion. Inside it, nothing can remain at rest. But unlike the event horizon, it is not a point of no return. If you're clever or lucky, you can still escape, stealing a little of the black hole's rotational energy in the process. This is how the universe performs one of its most fascinating tricks. It lets energy emerge from a place that seems to devour everything. In 1969, physicist Roger Penrose proposed an audacious idea. If you dropped an object into a spinning black hole and split it in two at just the right moment, one half could fall into the hole, while the other escaped with more energy than the original. The black hole's spin would slow slightly, paying the energy cost. It was called the Penrose process, and it suggested that even from the edge of oblivion, motion and power could be drawn back into the cosmos. We've since discovered that something like this happens naturally. When magnetic fields tangle in the swirling plasma near a spinning black hole, they can channel its rotational energy outward. The result is one of the most spectacular sights in the universe: colossal jets of light and matter streaming from the poles at nearly the speed of light. These jets can extend for thousands of light years, piercing through galaxies, shaping them, feeding them with energy. The black hole's hunger, paradoxically, becomes a source of creation. The more astronomers study spinning black holes, the more they realize how common they are. Nearly every supermassive black hole seems to spin, some gently, others violently, their rotation maintained by the steady inflow of gas and stars. The faster they spin, the more they distort space and time around them. In a sense, they are cosmic turbines, engines that convert gravity into motion, chaos into energy. Inside the ergosphere, time itself behaves strangely. To an outside observer, everything slows, dragged by the twisting geometry. A photon traveling with the spin may escape easily, while one moving against it might never leave. It's like swimming in a river where the water itself is time, and the current changes depending on your direction. Here, even the meaning of rotation becomes relative. You are no longer orbiting around the black hole, you are being carried with the very flow of space-time. At the event horizon, the spin reaches its ultimate limit. The black hole cannot rotate faster than light, but it can approach that speed closely enough that time warps beyond imagination. A clock, falling towards such a hole, would seem to slow infinitely, its final moment stretched across eternity. And yet, from its own perspective, everything would feel smooth. Time would pass normally, the fall continuing uninterrupted. The black hole's spin blurs the boundary between perception and physics, between what is and what can be seen. It's as though the universe, at its most extreme, is telling us something subtle, that movement and time are inseparable, that to exist is to rotate, to flow, to turn. If you listen closely, not with your ears, but with your imagination, you might almost hear it. The slow whirl of space-time, the soft hum of energy being pulled and released. The light flickers in curved paths. The stars beyond appear to dance, distorted and beautiful. You feel weightless, suspended in the current of gravity itself. There's something hypnotic about it, this vision of motion without sound, of power without violence. It's a reminder that even the most unimaginable forces can possess grace. As you breathe, you might notice a rhythm in your own body, a slow turning of breath, a cycle between inhale and exhale. The same pattern, the same symmetry, echoed across the universe. The cosmos spins, and so do we. Eventually the energy fades, the jets cool, the glow around the black hole dims, space untwists, gradually, and silence returns. But the imprint of that motion remains. The galaxies shaped by those jets continue to evolve, their stars forming, their planets orbiting, their civilizations perhaps looking up and wondering what made their skies glow so long ago. All of it born from the spin of nothingness. So, tonight, as you close your eyes, picture that silent motion space-time itself, flowing like silk around a hidden heart. Let it slow your thoughts, ease your breath, draw you gently inward. The universe is turning, endlessly, softly, like a lullaby sung by gravity. And in that slow rotation, somewhere between time and eternity, you too can rest. The deeper one looks into the dark, the more astonishing it becomes. For centuries, black holes were imagined as cosmic drains, places where everything ends. Yet the truth is far more mysterious. In their hunger, they also create. In their silence, they roar. From the very edges of nothingness, they send out rivers of light that cross galaxies and illuminate the deep. These are the relativistic jets, narrow beams of energy launched from the poles of a feeding black hole. They blaze outward at almost the speed of light, stretching for thousands, sometimes millions of light years. Within them, magnetic fields coil like serpents of plasma, guiding streams of charged particles that glow across the electromagnetic spectrum, radio waves, X-rays, and the faint blue shimmer of synchrotron light. To watch one of these jets is to witness the universe reversing its own logic. From darkness comes radiance, from gravity, flight. No one fully understands how they form. Matter falling into a black hole should simply vanish beyond the event horizon, and yet, somehow, some of it escapes. Scientists believe the key lies in magnetism. As the accretion disk spins, it twists the black hole's magnetic fields into tight spirals. These magnetic lines act like rails, channeling some of the inflowing matter back outward at tremendous speeds. It's a bit like a cosmic paradox. While one part of the disk falls inward, another is flung away, accelerated by the black hole's own spin. The process converts rotational energy into motion, the same principle that drives the turbines of stars and planets, but here magnified to scales beyond imagination. The result is breathtaking. Two luminous beams pierce the universe in opposite directions, perfectly aligned with the black hole's axis of rotation. They slice through interstellar clouds, light up nebulae, and sculpt the shapes of galaxies. Some of the most powerful jets ever observed come from quasars, galaxies whose central black holes are actively feeding. These jets shine brighter than all the stars in their host galaxies combined. They can extend for millions of light years, linking galaxies together like luminous filaments in the cosmic web. Astronomers have even found jets that predate our solar system, ancient streaks of radiation still glowing from when the universe was young. Each one is a relic of creation, a message written in light that says, even gravity can give. When telescopes capture them, the images seem surreal, thin lines of blue and white shooting across the black of space, ending in vast lobes of radio light. These are shock fronts, where the jets strike intergalactic gas and ignite it. Entire clusters of galaxies are warmed by this invisible fire. It's easy to forget, when looking at such fury, that the power comes from something smaller than a solar system. A supermassive black hole, perhaps a few 100 billion kilometers across, generating beams that stretch across the universe. All that energy begins with a single, silent spin. The jets themselves are nearly weightless, yet they carry enough force to shape galaxies. They prevent new stars from forming too quickly, regulate the balance of gas, and seed the surrounding space with heavy elements forged in the heat of creation. Without them, galaxies might collapse under their own abundance or drift into chaos. With them, the cosmos breathes a steady cycle of destruction and renewal. There's something profoundly poetic in this idea, that darkness gives birth to light, that the most consuming force in nature can also illuminate. Imagine floating near one of these jets. You would see two enormous pillars of radiance emerging from the poles of the black hole, glowing blue-white against the void. They shimmer and pulse, their edges flickering with turbulence. The magnetic fields twist them into helixes, like braided ropes of lightning stretching across eternity. You wouldn't hear them, but you would feel their vibration, the low, continuous hum of energy moving faster than any storm in the known universe. It's as if the black hole itself is exhaling light, releasing what it cannot keep. These jets are not only beautiful, they are messengers. Their radiation travels across billions of light years, carrying clues about the earliest epochs of the cosmos. When astronomers detect their signals, they are looking back in time, glimpsing the infancy of galaxies, the first sparks of structure forming out of chaos. Some scientists even believe that the balance of life itself, the chemistry that makes planets like ours possible, owes its existence to black holes. The heavy elements scattered by these jets may have seeded future solar systems, enriching the dust clouds that would one day become Earth. In this way, every atom in your body might carry a trace of a black hole's breath. You and I, and everything we know, may be the quiet afterglow of ancient jets that once burned through the newborn universe. If you think about it that way, black holes stop being symbols of death. They become symbols of renewal, cosmic forges that recycle matter and light. The darkness that swallows also gives back. The void is not emptiness. It is the cradle of everything that will come next. So, as you breathe in, imagine that faint energy, the relic of old starlight, the whisper of plasma that crossed time itself flowing gently into your lungs. The universe that once burned in those jets still moves within you. Every inhale carries the memory of a billion suns. Every exhale returns it to the cosmos. The jets fade eventually. Their light weakens. The black hole slows its spin and quiets again. But the mark they leave, the warmth, the heavy elements, the pattern of galaxies endures. When the energy is gone, the silence that follows is not emptiness. It is peace. The light has done its work. Creation has spoken. And somewhere, in another corner of the sky, a new black hole awakens, and the cycle begins again, the universe breathing, glowing, feeding, dreaming. So let that image stay with you as you drift toward rest. Two pillars of light streaming from the heart of darkness, carving the quiet with their gentle fire. The cosmos, forever painting itself anew, using even its shadows as brushes of gold. In the heart of nearly every galaxy, beneath clouds of stars and dust, lies a secret architect, a supermassive black hole. Silent, patient, and unseen, it shapes everything around it without ever revealing itself. The stars that form, the gas that flows, the very rhythm of the galaxy's life, all are influenced by that invisible presence. It's almost poetic. The most dominant force in a galaxy hides behind a mask of darkness, yet it is the reason galaxies exist in the first place. Without these black holes, the cosmos as we know it would look utterly different, dimmer, quieter, less organized, perhaps even lifeless. Scientists used to think of black holes as isolated destroyers, feeding on anything that strayed too near. But we now know they are builders as much as they are consumers, the quiet engineers of galactic evolution. Every galaxy has a story, and at the center of that story lies a gravitational anchor. The Milky Way has Sagittarius A*, weighing 4 million suns. The giant elliptical galaxy M87 harbors 6 billion times more massive. Some are heavier, still monstrous black holes, with the mass of tens of billions of suns sitting at the hearts of the largest galaxies in the universe. Their gravity binds everything around them. Stars orbit them the way planets orbit suns. Gas clouds spiral in slow motion, feeding the black hole when they drift too close. Yet these black holes do more than pull, they also regulate. When they feed, they release torrents of radiation and outflows that heat surrounding gas, preventing it from collapsing too quickly into new stars. It sounds paradoxical, something that devours matter, helping to preserve balance. But that's exactly what happens. By controlling when and where stars can form, these black holes determine the shape and character of entire galaxies. They are, in a sense, cosmic gardeners pruning the excess, ensuring longevity. Consider a galaxy as a living being. Its stars are like cells, its spiral arms like veins, its interstellar gas like breath. At its heart, the black hole is its pulse, slow, steady, and ancient. When the galaxy grows restless, when too much gas gathers at the core, the black hole awakens. It feeds, releasing bursts of radiation that push the gas outward. Star formation slows, the galaxy calms, and balance returns. When the gas thins again, the black hole falls back into sleep. This dance of feeding and resting has been going on for billions of years. Even galaxies far apart seem to evolve in harmony, guided by the same invisible rule, that hunger and creation must coexist. Astronomers have discovered an astonishing connection between galaxies and their central black holes, known as the M-sigma relation. It shows that the mass of a black hole is directly linked to the velocity of stars in its galaxy. The bigger the black hole, the faster the stars move, even those far from the center. Somehow, through gravity and time, the black hole and the galaxy grow together, like partners in an ancient waltz. This discovery changed our understanding of the universe. It means black holes aren't just passengers inside galaxies, they're co-authors of their evolution. Every star that twinkles in the sky, every nebula that glows in distant space, may owe its existence to a black hole that set the stage long ago. But this influence isn't violent. It's subtle, measured, and endlessly patient. Over millions of years, the radiation from the black hole's accretion disk spreads outward, carrying heat and momentum that sculpt the interstellar medium. The gas cools, condenses, and eventually gives birth to new stars, but never too quickly. The balance between feeding and creation is delicate, like the inhale and exhale of a cosmic breath. You could almost imagine the black hole as a silent conductor, leading an orchestra of stars. Every burst of radiation, every gravitational wave, every flare of energy plays a part in the galaxy's melody. The rhythm is slow. One measure may last 1,000,000 years, but it is music all the same. Sometimes, the black hole's influence extends far beyond its home galaxy. The powerful jets we saw in the last section can travel for millions of light years, injecting energy into the intergalactic medium, triggering or suppressing star formation in neighboring galaxies. In this way, one black hole can shape an entire cluster of galaxies, its actions rippling outward across the cosmic web. Even after the jets fade, their imprint remains vast cavities carved in clouds of gas, trails of magnetism that linger for ages. Long after the black hole has gone quiet, its design persists, written into the shape and motion of the universe. It's humbling to think that we live inside one of these great architectures. The Milky Way, with its spiraling arms and glowing core, owes its balance to the unseen pull of Sagittarius A*. Every sunrise, every quiet night sky, every constellation you trace above your bed, all of it exists within the gravitational rhythm of that hidden heart. If you could look from far away from another galaxy, perhaps you'd see the Milky Way as a slow-turning whirl of light, bound together by darkness. The stars at the edge would shimmer softly, unaware that their dance is choreographed by something they cannot see. And maybe that's true for us too. We move through life, orbiting invisible forces, memory, hope, love, curiosity, each shaping our path as quietly as gravity. When you gaze up tonight, remember that the stillness of the sky hides motion on a grand scale. The galaxies are not static pictures, they are vast, breathing beings, held together by unseen architects. Black holes do not rule with fear. They guide through balance. Their silence is the foundation upon which creation rests. So, close your eyes now. Picture your own galaxy turning slowly in the dark. Feel its center pulling gently, holding everything in harmony. Let that sense of gravity become calm in your chest, a reminder that stability too can be born from mystery. The universe is not a chaos of stars. It is a cathedral built around invisible hearts. And tonight, beneath its silent arches, you are part of its design. Not all light can be seen. In fact, most of what the universe emits never touches the human eye. The cosmos glows in whispers in radio waves, infrared warmth, ultraviolet shimmer, X-ray flashes, and gamma bursts. Together they form an unseen rainbow, a vast invisible orchestra of energy. When black holes feed, this hidden light becomes their voice. It's how we hear their song across the vacuum. If you looked through an ordinary telescope, you would see nothing at all, only the surrounding stars, calm and indifferent. But switch to a radio array or an X-ray detector, and suddenly the darkness comes alive. Rings of radiation bloom around the black hole. Invisible jets slice through the void. Every frequency reveals a new layer of truth, each one a translation of gravity into light. Astronomers listen to these wavelengths the way musicians read notes. Radio telescopes capture the long, slow hums of plasma flowing outward. Infrared sensors trace the soft heat of dust warmed by the accretion disk. X-ray observatories detect the frantic flickers of matter spiraling inward at nearly light speed. And beyond all that, satellites tuned to gamma rays record the most violent outbursts, the final screams of atoms torn apart by gravity. Each band of energy is a different instrument in the same cosmic symphony. For decades, scientists have built machines to see what eyes cannot. The Very Large Array in New Mexico listens to black holes through radio waves. NASA's Chandra X-ray Observatory watches them in high-energy light, where the universe burns hottest. The James Webb Space Telescope, floating far from Earth, peers in infrared, tracing the faint warmth of ancient galaxies where black holes first began to feed. Each of these instruments adds a brushstroke to an invisible painting, the true portrait of the cosmos. The result is a picture that is both beautiful and humbling, the darkest objects shining brightest when viewed through eyes made of metal and math. When their data are combined, something extraordinary appears. The jets, the disks, the swirling gas clouds all merge into one glowing image, alive with motion. The black hole itself remains hidden, but its surroundings tell its story in color and rhythm. What we see is not the black hole's destruction, but its energy translated into language we can perceive. It's easy to forget that light is only one form of communication. Gravity sends waves, two ripples through space-time that move more slowly than light, but carry just as much information. When black holes collide, those ripples stretch across the cosmos, and instruments like LIGO and Virgo record them as faint vibrations. They are, quite literally, the universe's low bass notes the sound of space ringing like a bell. Each detection is a conversation between matter and void, an echo in a spectrum far beyond human senses. We can't see it, we can't touch it, yet the data trace the story of creation itself. Think of it this way. When you listen to the rain, you don't see every drop, you sense the pattern. The universe works the same way. Radio waves are the rain of distant galaxies. Infrared light is their warmth. X-rays are their lightning. And somewhere behind it all, gravity keeps the rhythm. When scientists translate these signals into sound, they discover melodies unlike anything on Earth, deep drones, sudden beats, and harmonics that rise and fall across centuries. Some frequencies vibrate slower than a human lifetime. Others pulse faster than a heartbeat. Together, they form the quiet music of existence. Even now, as you sit here listening, The air around you is filled with invisible waves. They pass through walls, through oceans, through your body. Radio signals from the dawn of the universe glide by without a sound. You are immersed in cosmic light that your eyes cannot see. Somewhere, billions of light years away, a black hole feeds. Its disk glows in X-rays. Its jets flash in gamma rays. Those photons leave their home and begin their long journey crossing clusters of galaxies, drifting through voids colder than any winter, passing quasars and nebulae, until, finally, a few of them reach Earth. They strike a telescope's mirror, or a detector's sensor, or even the thin layer of your own atmosphere, and their story continues. That story might have begun before our planet even existed. Every observation we make, every particle of light we collect, is a memory from the past. When we look at a black hole through X-rays or infrared, we're not seeing it as it is, we're seeing it as it was, perhaps millions or billions of years ago. The light that left its disk has been traveling all that time just to reach us now. It's almost as if the universe keeps a record of itself in waves of energy, each one an echo that never truly fades. And when we tune our instruments correctly, we can listen to those echoes, piecing together the history of everything that ever shone. So as you breathe in, imagine those invisible lights streaming gently around you, soft waves passing silently through the night, carrying messages from far beyond. Let them drift through your mind like whispers from ancient stars. The visible world fades and the hidden one unfolds. You don't have to see the light to know it's there. You don't have to understand every wavelength to feel the quiet rhythm of the cosmos. Just listen, not with your ears, but with that still part of you that recognizes wonder. The universe is speaking all the time, in colors beyond sight, in vibrations beyond sound. And somewhere, through the long hum of radio waves and the pulse of X-rays, you might almost hear it breathe. A soft echo in the dark, a reminder that even silence shines. At the center of our Milky Way, beyond the clouds of dust and the tangle of stars, lies a region so quiet that it almost seems sacred. Astronomers call it Sagittarius A, times a name that sounds technical, almost modest. But what it hides is a sleeping giant, 4 million times the mass of our Sunday. It is our galaxy's heart, our invisible anchor, our local gate into the unknown. If you could strip away the gas and dust that veil the galactic core, you would see a strange light show. Stars whip around an unseen point at incredible speeds, some completing an orbit in less than 20 years. One of them, known as S2, races through space at nearly 5,000 kilometers per second. And yet, at the very center of all this motion, there is nothing visible. No star, no cluster, only darkness. That absence is Sagittarius A*. For most of human history, no one imagined such a thing existed. The bright river of the Milky Way was thought to be eternal and calm. But in the late 20th century, radio telescopes began to whisper a different story. They detected faint pulses of energy coming from the constellation Sagittarius, near the Archer's Bow. Whatever lay there was compact, no larger than the orbit of Mercury, yet it weighed as much as millions of suns. Only one explanation fit: a supermassive black hole. Since then, astronomers have watched this dark heart with obsessive devotion. They have mapped the orbits of nearby stars, measured the flares that flicker unpredictably from its surroundings, and listened to the X-ray sighs that drift through space when it briefly awakens to feed. Each flare is a heartbeat, a sign that even in its sleep, the galaxy's center dreams. In 2022, after decades of patient collaboration, humanity finally saw it. Using the Event Horizon Telescope, the same global array that captured the image of the black hole in M87, scientists revealed the first direct picture of Sagittarius A*. It wasn't a sharp photograph. but a glowing ring of radio light encircling darkness, an orange halo swirling around a shadow. The image confirmed what theory had predicted. The center of the Milky Way is not empty, but filled with curved space-time, an abyss wrapped in fire. The light we saw did not come from the black hole itself. It came from hot gas, orbiting at nearly the speed of light, from particles colliding, twisting, and releasing their final energy before crossing the event horizon. What the camera captured was the echo of matter's last moment, a cosmic farewell frozen in radio waves. For the scientists who worked on the project, that picture was more than data. It was intimacy. They had, in a sense, looked directly into the heart of home. Somewhere, buried under 26,000 light-years of dust, the Milky Way's heartbeat had been caught in a frame. The image reminded many of a candle, the same fire that gives warmth before darkness. Some called it the eye of the galaxy. Others said it looked like a portal, but perhaps the truest description is simply this: a mirror. For when we stare at Sagittarius A*, we glimpse not just a distant object, but the structure of reality itself, how space bends, how time slows, how light can circle forever without escape. Around Sagittarius A*, the environment is anything but peaceful. Gas clouds drift inward, occasionally colliding, forming miniature flares that blaze for hours before fading. Sometimes an entire star wanders too close, and its outer layers are stripped away, feeding the black hole in a brief, brilliant meal. Between those feasts, the region remains silent, punctuated only by the slow motion of nearby stars. The balance is delicate. Too much material, and Sagittarius A times would erupt into a quasar, flooding the galaxy with radiation. Too little, and it would vanish entirely from our instruments. For now, it rests in a middle state quiescent, breathing faintly, waiting for the next chance to feed. Even its hunger shapes us. The jets and winds that once blew from its accretion disk long ago may have influenced the Milky Way's spiral arms, guiding where stars could form and where space would remain empty. We live, quite literally, in the afterglow of its moods. Astronomers sometimes describe Sagittarius A times as a gentle giant. Compared to the ferocious quasars of distant galaxies, ours is quiet, almost humble. But its gravity still rules every star you see in the night sky. The Sun itself orbits this dark mass, taking more than 200 million years to complete a single revolution. All of us, every world, every beam of light in the Milky Way are part of that slow dance. When you look up on a clear night and see the Milky Band stretching across the heavens, you're looking edge-on into that spiral, toward the place where Sagittarius A times hides. Every point of starlight is moving, orbiting, caught in a gravitational waltz we can't feel but are always part of. It's easy to forget that the center of our galaxy is also the center of our story. Without Sagittarius A*, the Milky Way would have no anchor. Its stars would scatter, its arms would lose their shape, its rhythm would dissolve. Instead, because of this dark heart, the galaxy holds together a luminous wheel spinning around an invisible hub. There's something deeply comforting in that idea, that even in our smallest moments of uncertainty, something vast and steady keeps everything in balance. A quiet gravity that expects nothing and yet gives everything its place. So, as you listen now, imagine drifting toward that distant center, through dust clouds and constellations, through the spiral arms that cradle suns and planets, until the night deepens and the stars begin to curve around an unseen point. You arrive at the edge of the black hole's light, that glowing ring where time bends and the universe pauses. You can feel it not as fear, but as calm. The pull is gentle, like a heartbeat deep within the sky. The same pulse that guides the stars also guides you, softly, without effort. And as the light flickers and the silence deepens, you realize that the galaxy is not cold at all. It is alive, breathing, held together by a single, patient heart, one that has never stopped beating since long before the first sunrise on Earth. The tale of Sagittarius A times is, in the end, the tale of us, of everything drawn together by invisible bonds, moving through time and darkness, guided always by the quiet gravity of home. Far from the calm of our solar neighborhood, in the crowded core of the galaxy, stars wander like restless travelers. They weave among clouds of gas, cross paths with hidden giants, and sometimes one of them makes a fatal mistake. It drifts too close to a black hole. There are few events in the universe as breathtaking or as tragic as what happens next. At first, nothing seems to change. The star glides silently through the void, brilliant and oblivious. Its surface glows with the steady warmth of fusion. Its gravity holds it in perfect balance. But beneath that serene surface, an invisible tide begins to rise, the pull of a black hole's gravity. The nearer the star drifts, the stronger the difference becomes between the pull on its near side and the pull on its far side. That imbalance stretches it, subtly at first, then violently. The black hole does not simply attract the star, it tears it apart. This is called a tidal disruption event, a cosmic catastrophe that transforms a star into ribbons of light. The same tidal forces that create the gentle rhythm of Earth's oceans here become instruments of destruction. Imagine the scene. The star elongates, its gases ripped into a glowing stream that spirals toward the black hole like liquid fire. As the stream wraps around the black hole, friction ignites it. The gas heats to millions of degrees, flaring brighter than an entire galaxy for a few short weeks. From Earth, this moment appears as a sudden burst of ultraviolet and X-ray light, a flash from deep space that fades slowly over months. To us, it's a passing spectacle. To the star, it's the end of everything it has ever been. Half of its matter falls into the black hole, adding to its mass. The rest is hurled back into the galaxy at incredible speed, a wave of glowing debris that carries traces of the star's last breath. For the black hole, it is a feast. For the universe, it is theater, a silent, radiant display of power. Telescopes around the world have recorded these events, giving them poetic names. ASSN 14 Li at 2019 Kiz, Swift J 1644 plus 57. Each one marks a star's final encounter with gravity's absolute edge. Each one tells us a little more about how black holes feed and grow. In some cases, the light from the event bends around the black hole before escaping, creating a ghostly echo known as gravitational lensing. The same flare appears multiple times in our sky, delayed by minutes or hours, as though the universe itself were replaying the memory. But there's more to the story than destruction. The gas flung outward after such an encounter doesn't vanish. It drifts through space, cooling and mixing with interstellar clouds. Over millions of years, it will become part of new stars, new worlds, and perhaps new forms of life. A single act of cosmic consumption becomes, in time, an act of creation. The atoms torn from that star may one day shine again in the light of another Sunday. It's a strange comfort that even endings here are beginnings wearing different names. If you could somehow watch this drama unfold up close, the sight would defy imagination. The sky would curve around you, warped by gravity. The shredded star would glow in bands of orange, blue, and white, its light twisting as it falls. Waves of radiation would sweep through space like tides of invisible fire. And, in the center, the black hole silent, still, absorbing everything. Not a monster, but a mirror, a presence so powerful that even light can only orbit it, never escape. You might expect horror, but what you'd feel is awe. The the strange stillness of inevitability, the beauty of surrender. In the end, everything in the universe moves toward balance. Stars burn, fade, and fall, and the matter they leave behind helps the cosmos remember itself. The data from these events teach scientists more than any theory could. By studying how the light changes over time, how it flares, fades, and shifts in color, astronomers can estimate the size of the black hole, its spin, even its appetite. They can tell whether it is calm or raging, gentle or voracious. Each tidal event becomes a kind of fingerprint, unique, fleeting, but forever recorded in the memory of light. And perhaps the most haunting part is how quiet it all is. No explosion, no noise, only light and motion, all of it taking place in perfect silence. The vacuum of space has no air to carry sound, no medium to translate chaos into noise. So the star dies soundlessly, a whisper swallowed by infinity. When you think about it, there's something deeply human in that image. A bright life drawn into a larger mystery, leaving behind ripples that continue long after the light is gone. We too are part of a cycle we cannot see in full. Moments of brilliance, moments of surrender, and the quiet continuity that connects them. As you listen now, imagine the gentle pull of gravity, not as violence, but as invitation, a reminder that everything eventually returns to the source. Even stars, even light, even thought. The universe is vast, but it wastes nothing. Every fall, every fading, every final glow becomes part of the next generation of brightness. So take a breath. Let your thoughts drift like starlight. Somewhere out there, another sun has wandered too close to a black hole and been transformed into a ribbon of light. The galaxy shimmers with its memory. Perhaps, when you close your eyes tonight, that same light, traveling for millions of years, will reach you at last, soft and unseen, touching your eyelids like the echo of a forgotten fire. The star that got too close is gone, and yet its light still falls. There are boundaries in the universe that cannot be crossed and still return. They are not walls or barriers, but conditions, thresholds, woven into the structure of reality. The most mysterious of them all is called the event horizon, the invisible frontier that surrounds a black hole. It marks the point where escape becomes impossible. Once crossed, not even light can turn back. Time and space trade places here. To move forward is to fall inward, and to resist is to stand still forever. The event horizon is where the known world ends and the unknowable begins. Imagine drifting toward it. You've come from the cold quiet of space, passing through the brilliant storm of the accretion disk. Ahead of you lies a darkness, so complete it seems to swallow thought itself. The ring of light glows behind you like a dying Sunday, and before you, only night. To an observer watching from far away, you appear to slow as you approach the horizon. Each second stretches, then freezes. Your image lingers just outside the edge, fading slowly to red as light loses energy in its climb out of the gravitational well. To them, you never truly fall. You become a ghost, suspended forever on the threshold. But from your own point of view, nothing unusual happens. You cross the line without noticing it. The stars behind you bend into a narrow halo and then vanish. There is no sound, no explosion, no moment of impact, only a quiet transition, the boundary between being seen and being gone. Inside, the laws of physics as we know them begin to tremble. The path of time turns inward. The flow of space collapses toward the singularity, the core where all dimensions meet. Every direction now leads forward in the same way that time leads forward in the ordinary world. To resist the pull is as impossible as resisting tomorrow. Yet this falling is not violent. It is the most natural motion in the universe. You are not being torn apart, not yet, but carried by gravity's perfect curve. In those last moments, you might even feel weightless, adrift in silence. The deeper you go, the more space stretches. Distances elongate, seconds pass differently, and light itself becomes trapped in loops around you. The inside of a black hole is not darkness in the usual sense. It is brightness folded in upon itself, so dense that it cannot escape its own reflection. Scientists have tried for decades to describe what happens beyond that threshold. The equations of Einstein's relativity predict the singularity, a point of infinite density, where space-time curves infinitely and all our theories break down. But what infinite really means there is uncertain. Infinity is not a number. It is a confession of ignorance. Some physicists think the singularity is not a point at all, but a bridge, a connection to another region of space-time, perhaps even another universe. Others imagine it as a quantum fuzz, where gravity and subatomic physics merge into a new, untested form of matter. A few dream that information, instead of being destroyed, is somehow preserved on the surface of the event horizon itself, encoded in light, like ripples on water. Whatever the truth, it remains hidden behind the veil. The event horizon does not let secrets escape, and yet, paradoxically, we can see its outline. The shadow it casts on the surrounding light is what gives black holes their haunting beauty. When the Event Horizon Telescope captured the first images of M 87 times and Sagittarius A*, what it revealed was not the hole itself, but its silhouette, a ring of light shaped by the warping of space-time. That ring is the Event Horizon's signature, the last light before forever. It is the border between the visible and the eternal, unknown. To stand on that edge, even in imagination, is to face the universe at its most honest. No illusions, no boundaries, just the truth that every form must eventually surrender to change. Think of the event horizon as a metaphor as much as a phenomenon. Every life has horizons, the places where one phase ends and another begins, where we cross from the familiar into mystery. Sometimes we resist them, clinging to the known. Sometimes we fall through them without choice. Either way, something new always waits beyond. Perhaps that's why the image of a black hole fascinates us so deeply. It's not merely about gravity, it's about transformation. What enters does not vanish. It becomes part of something greater, something beyond comprehension. The event horizon is the universe's way of saying that endings are not truly ends. They are horizons of becoming. If you close your eyes now, you can imagine standing at that threshold. The light of the world is behind you, glowing faintly like memory. Ahead, there is silence and potential. You feel the pull, the slow drift forward, the calm surrender to inevitability, and in that surrender, there is peace. You are not falling into darkness. You are falling into unity, into the same gravity that holds galaxies together, the same mystery that turns death into creation, the same silence that has guided the stars since the beginning. As you cross that line, you realize the universe has no edge. It only folds inward, deeper and deeper into itself. And maybe that is what eternity really means. Not endless time, but endless depth. The event horizon is the frontier of reality, a place that no eye can see, no voice can return from. Yet every beam of light in the cosmos bends to acknowledge. It is the boundary of all knowing, and beyond it lies the heart of existence itself. So breathe softly. Imagine that line stretching before you, a ring of light circling a quiet center. You stand at the edge of forever, watching the last photons spiral into the dark. And as you drift closer, the stars blur, the noise fades, and time slows into stillness. Not an ending, not a fall, just a return into the calm gravity that made you. From far away, a black hole looks like a mouth in space. But to those who drift near it, it becomes something stranger, not a place of death, but a distortion of time itself. Imagine watching an object fall toward the event horizon, a fragment of rock, a particle of light, a traveler of thought. As it approaches, its motion seems to slow. The closer it gets, the slower it falls, until it appears frozen at the edge. From a distance, you would swear it never truly crosses, only fades, its light stretched to red, its final moments drawn out into eternity. This is not illusion. It is the shape of time near gravity's deepest well. Einstein once wrote that gravity is not a force pulling things together. It is the bending of space and time caused by mass. The heavier something is, the more deeply it curves the stage on which reality unfolds. Near a black hole, that curve becomes so extreme that even time, the most universal current of all, begins to twist and slow. Seconds stretch, minutes dilate, hours unravel into forever. The clock of the universe beats differently here. To an observer safely far away, time seems to stop for anything that ventures near a black hole. But to the thing falling in a fragment of dust, a star, a person, everything feels perfectly normal. It continues to move, to breathe, to fall. The paradox arises because gravity warps not only motion, but perspective. There is no single rhythm of the cosmos. Every point in space has its own tempo, its own measure of duration. Near a black hole, that tempo becomes almost silent. The same phenomenon happens, faintly, around every massive object. Your own body, your phone, your breath, all experience time differently, though imperceptibly so. A clock placed on the floor runs slightly slower than one on a shelf because it sits closer to Earth's gravity. The difference is too small to notice, but it exists. A black hole is simply the ultimate expression of that truth. Gravity is not violence, it is patience, an infinite patience that slows time until it nearly stands still. Scientists call this gravitational time dilation. And it is not just theory. We've measured it with satellites, with atomic clocks, with signals sent from spacecraft near massive planets. It is real, and it governs everything from GPS navigation to the flow of galaxies. But near a black hole, the effect becomes profound enough to reshape meaning itself. A single hour near the event horizon could equal centuries or millennia for someone watching from afar. Picture this. A spacecraft drifts close to the edge of a supermassive black hole. The crew hovers in orbit, observing the swirling light below. For them, the minutes pass normally. They speak, breathe, record data, share thoughts. When they return home, if they ever could, they would find their world aged beyond recognition. Cities gone, stars shifted, languages forgotten. In the black hole's gravity, time itself becomes elastic, stretched beyond the imagination of human hearts. It's a strange comfort, perhaps, to know that the universe holds pockets where time slows to almost nothing. They are like still lakes in the flowing river of eternity. If you were to fall inward, you would not notice the slowing. Everything around you, your heartbeat, your breath, your thoughts would continue in rhythm. The distortion lies not in your own frame of reference, but between you and everything you've left behind. To you, the universe above would appear to accelerate galaxies spinning faster, light blue shifting into brilliant flashes, the entire cosmos rushing forward in time. You would, in effect, watch the future unfold in a single blinding instant. Stars would age, die, and be reborn. Entire civilizations might rise and vanish. The background radiation of the universe would cool, then fade into darkness, and then, all at once, time itself would dissolve into the singularity. In falling toward forever, you would glimpse all of forever at once. For centuries, poets and philosophers have searched for metaphors to describe time, a river, a wheel, a thread, a song. But perhaps the truest metaphor is a spiral always moving forward, yet always returning to its center. Around a black hole, that spiral becomes literal. Matter and light wind inward, circling endlessly until they vanish. It is time-given form a whirlpool of moments, turning towards stillness. You can almost imagine the universe itself breathing through these spirals. Inhale creation, exhale collapse. And somewhere, caught between the two, we exist tiny observers, watching from the shallow end of time's great ocean. Physicists often ask, what happens to time inside a black hole? The equations suggest that time and space exchange roles, that to fall inward is to move forward in time. The singularity, then, is not a point in space, but a moment in the future that cannot be avoided. Everything that crosses the event horizon is simply traveling toward its inevitable tomorrow. In that sense, black holes are not endings at all. They are futures intense, compressed, and absolute. And maybe that is why they feel so haunting to us. Because deep down, we know that we too are spiraling toward our own horizon of time. Every heartbeat carries us closer to a silence we can neither see nor resist. But like the black hole, what waits beyond may not be absence. It may be continuation in another form. So, as you breathe slowly now, imagine that spiral of time, the quiet curve, drawing everything toward unity. Each thought, each memory, each second of your life moves along that same graceful path, winding inward, not to disappear, but to merge. The stars, too, follow the same rhythm. They collapse and reignite. The galaxies spin. The universe expands, then perhaps will contract again. Nothing is wasted. Nothing is truly lost. The slow spiral of time is not decay. It is a dance. And if you listen carefully, not with your ears, but with your sense of stillness, you can almost hear its music. It's the same rhythm that moves the tides, the same pulse that shapes gravity, the same heartbeat that once began in the first second of the cosmos and still echoes now. A soft, endless turning, a whisper that says, nothing ever ends, everything only deepens. Long before the Milky Way found its graceful spiral shape, before stars like our sun were even born, the universe was young, wild, chaotic, and full of light. Back then, black holes were gluttons. They grew faster than any living thing we can imagine, devouring matter in furious bursts that lit the early cosmos. It was the age of cosmic hunger, a time when galaxies were still children, and the laws of balance had not yet settled into place. When astronomers look deep into space, they are also looking back in time. The farther their telescopes reach, the younger the universe becomes, and what they find there is astonishing. Black holes that seem impossibly large, already billions of times the mass of the sun, existing when the universe was less than 1 billion years old. How did they grow so quickly? The question still unsettles scientists today. Even the fastest known processes of accretion, the steady fall of gas and dust, can't easily explain such enormous sizes in such short cosmic time. Some believe that these monsters began as the collapsed hearts of the first generation of stars, enormous suns hundreds of times larger than ours, burning bright and dying fast. Others suggest that they were born directly from the collapse of giant clouds of gas, direct collapse black holes, skipping the stellar phase entirely, going straight from cloud to abyss. However they began, they grew fast, feeding on anything within reach. The early universe was crowded. Gas was thick and warm. Stars were forming everywhere, and collisions between galaxies were frequent. When two young galaxies merged, their central black holes found each other and began to dance a spiral of attraction that ended in a single, larger being. Each merger released gravitational waves, ripples that carried energy across the young cosmos. Each collision added mass and momentum to the survivors, helping them grow faster still. The space around them was no calm emptiness. It was a storm of radiation, magnetic fields, and newborn stars. In that glowing chaos, the black holes at the centers blazed like cosmic furnaces, surrounded by accretion disks brighter than entire galaxies. The universe, though only a few 100 million years old, glittered with their light. We call these ancient feeders quasars, short for quasi-stellar radio sources. When they were first discovered in the 1960 seconds, astronomers thought they were stars, because their light was so concentrated and distant. Only later did they realize that these points of brilliance were galaxies powered by central black holes, devouring matter at nearly the speed of light. Some quasars are so luminous that they could outshine 10 trillion suns. They can be seen across more than 13 billion light-years of distance, their light leaving when the universe was barely 1/10 its current age. Imagine that. The glow of ancient hunger, still reaching us now, long after the hands that fed it have vanished. At their peak, these feeding frenzies transformed the shape of the universe. The radiation from quasars carved bubbles of ionized gas around them, stripping electrons from atoms and making space transparent to light for the first time since the Big Bang. This period is called the epoch of reionization, the dawn when darkness lifted and the cosmos became visible. Black holes, in their appetite, helped illuminate the universe. They turned the opaque fog of creation into a sea of stars. It's almost paradoxical. The darkest objects in existence became the first beacons of cosmic light. But this hunger came with consequences. The same radiation that cleared the fog also scorched the gas that would have formed new stars. For a while, the universe burned too brightly for its own good. Galaxies struggled to grow. Some black holes exhausted their food supply and fell silent, entering long periods of dormancy. Others merged into larger ones, anchoring the giant galaxies we see today. In that sense, our own Milky Way carries a legacy of those early feasts. Sagittarius A*, though calm now, was once likely a quasar itself, a ravenous center shining fiercely across young space. Its quietness today is a kind of peace after hunger, the stillness of a predator that has already eaten its fill. When astronomers use radio and infrared telescopes to peer back in time, they sometimes catch glimpses of these ancient giants, not as monsters, but as teachers. Their light carries the record of how gravity shaped everything. Every photon tells us how fast matter fell, how hot it burned, how quickly the universe organized itself into order. The more we learn, the more it seems that black holes didn't just feed on the cosmos, they helped build it. Their jets seeded distant clouds with magnetic fields. Their radiation guided the birth of galaxies. Even their mergers set the rhythm for cosmic structure, creating the filaments and voids that weave through space like veins in a living body. The young universe was not peaceful, but it was alive. Black holes were not destroyers, but catalysts. Every flicker of light we see from that ancient time is a reminder that creation is rarely gentle. It comes from friction, from heat, from the gravitational embrace of opposites. If you could have watched the early cosmos unfold, you would have seen a landscape of radiant storms, galaxies crashing together, stars exploding, matter spiraling into black holes that flared like miniature suns. The sky would have glowed with gold and violet, the colors of high-energy light. There would have been no silence, only the continuous hum of a universe finding its voice. And in the center of that song, the black holes kept the rhythm they're feeding, their growth, their endless turning. Now, billions of years later, we live in the calm after that symphony. The bright quasars have dimmed, the universe has expanded and cooled. The frenzy has faded into quiet harmony, but the echoes remain. Every atom in your body, every spark of starlight above you, carries a trace of that ancient fire. You are, in a sense, the cooled ash of that primordial feast, the gentle afterglow of the universe's wild youth. So as you close your eyes, imagine that first dawn. The galaxies spinning faster than they do now. The black holes blazing like candles in the newborn night. The cosmos, alive with hunger and creation, whispering the same truth it still whispers now. Even in chaos, there is order. Even in darkness, there is light. And the heart of that balance, the hungry, radiant heart, is still beating somewhere out there among the stars. Galaxies are not lonely. Across billions of years, they drift, collide, and merge in slow, stately dances that reshape the cosmos. When two galaxies meet, their stars rarely collide. Space is simply too vast, but their gas, dust, and gravity intertwine in breathtaking patterns. Spiral arms tangle like ribbons. Tidal tails stretch for hundreds of thousands of light years, and whole constellations of new stars ignite in the wake of the encounter. Yet hidden beneath all that luminous beauty, something darker stirs. In the core of each galaxy lies a supermassive black hole, and when the galaxies merge, those black holes begin to circle one another, two invisible giants, bound by a gravity that will not let them go. It is one of the most majestic and terrifying dances in the universe, the merging of black holes. At first, the two monsters orbit at a distance, each one wrapped in its own cluster of stars. Their mutual pull distorts the galaxies' shapes, funneling gas toward their centers. As the galaxies blend into one another, their black holes spiral closer, their paths tightening with each revolution. For millions of years, they move like twin storms in a cosmic sea, spinning faster as they draw near. The energy they lose in the process doesn't vanish. It radiates away as gravitational waves, ripples in space-time that spread through the universe like the sound of a deep, invisible drum. These waves travel forever. Billions of years later, they may reach distant worlds, shaking the instruments of observatories like LIGO or Virgo, tiny tremors in the quiet of human laboratories. To us, they are whispers, signals that tell of colossal events unfolding in the darkness long before our world existed. Eventually, the black holes come close enough that their orbits decay rapidly. Gas and dust swirl around them, forming twin accretion disks that glow like halos. The gravitational field between them becomes so intense that light bends and doubles, producing ghostly echoes of each black hole mirrored in the other's gravity. For a brief time, the two giants appear as one, a flickering, chaotic blaze surrounded by jets of plasma shooting outward. And then, in an instant shorter than a heartbeat, they collide. The merger releases more energy than all the stars in the universe combined emit in that same moment. It's not energy of light, but of space-time itself, the universe ringing like a bell struck by creation. The new black hole that forms is larger, heavier, and calmer, spinning with the combined momentum of both parents. Around it, the chaos settles into silence once again. What remains is not destruction, but renewal. The gravitational shockwaves reshape the galaxies around them, stirring gas into new regions, triggering fresh bursts of star formation. The newborn black hole, now the dominant heart of a new, merged galaxy, becomes the architect of its future. Astronomers have captured snapshots of galaxies mid-collision, the antennae, the tadpole, the whirlpool. In each one, bright knots of new stars shine amid the twisted debris, proof that even in the most violent encounters, the universe chooses creation. Somewhere among those collisions, our own Milky Way's fate is already written. In about 4 billion years, it will merge with the neighboring Andromeda galaxy. The night sky will bloom with 1,000 new stars, and deep in the core, Sagittarius A times we'll meet Andromeda's central black hole in a gravitational embrace that will last eons. When that day comes, if humanity or any descendants still exist, they might look up and see the heavens filled not with fear, but with light. Scientists studying these mergers call them cosmic laboratories. They allow us to test the very limits of physics. The patterns of gravitational waves reveal the mass, spin, and alignment of the merging holes, the fingerprints of the universe's most extreme objects. Every detection refines our understanding of Einstein's equations, confirming that even under unimaginable pressure, space-time still follows the same laws. But beyond science, there's something almost spiritual in the image of two invisible hearts uniting after eons apart. It's a reminder that even the most powerful forces in existence are driven by attraction, by the pull to become one. Imagine the final moments of such a merger. Two black holes orbit each other dozens of times per second, drawing closer with every turn. The light from the surrounding gas flickers with each revolution, modulated by the rhythm of their gravity. Then, suddenly, the two horizons touch. Their edges blur. The ripples of space-time surge outward, faster than any sound could ever travel. The merged whole quivers for a moment, its shape wobbling like a struck bell, and then it settles into stillness. Silence returns, but the echo continues, the low, steady hum of gravitational waves flowing outward through the universe, carrying the memory of what just occurred. Somewhere, countless years later, that echo brushes across Earth, and our detectors register it as a faint chirp, a brief pulse of meaning in the static of space. We record it, name it, and know that two ancient beings have just become one. When galaxies merge, we are witnessing the universe's way of growing up. Chaos becomes order, two become one, and from the collision of darkness comes light. So, as you rest now, picture those twin spirals of stars meeting in the deep. Imagine the black holes circling each other, patient, inevitable, magnificent. Their gravity hums softly through the fabric of creation, through the stars, through your breath. The same pull that binds galaxies also binds your heart to the rhythm of existence. The same merging that creates new worlds also unites the smallest atoms. There is no separation, only gravity finding harmony. The monsters of merging galaxies are not villains. They are composers writing the future of the cosmos in waves too slow for us to hear. And long after the light of their collision fades, their melody continues, echoing through space-time like a lullaby from the beginning of everything. Listen closely. You might already feel it, the deep, quiet pulse of union that keeps the universe whole. If you could listen to space, really listen not through air or echo, but through the vibration of space-time itself, you would hear the universe sing, not loudly, not like thunder or wind, but in low, rolling notes that last for seconds or years. The music of gravity, traveling across the dark. When two black holes collide, they do not explode in fire. They merge in silence. Yet that silence ripples. It moves through everything, through galaxies, through clusters, through the atoms in your hands. The sound of that ripple is not a metaphor. It is a real wave, a faint tremor in the fabric of reality. In 2015, the world heard that sound for the first time. The detectors of LIGO twin observatories in Louisiana and Washington recorded a signal that lasted less than half a second. It was faint, almost imperceptible, a chirp rising quickly in pitch, then fading into nothing. But in that instant, humanity had caught the echo of two black holes colliding a billion light-years away. Each of those black holes was roughly 30 times the mass of our Sunday. As they spiraled together, they moved faster and faster, their orbits tightening, their energy radiating away as gravitational waves. In their final fraction of a second, they were spinning at half the speed of light. Then, in one last revolution, they merged, and 3 suns' worth of mass vanished into pure energy. That energy became the wave that reached us, the first whisper of gravity's hidden song. To most ears, the sound is underwhelming, a faint chirp, like a drop of water in a cave. But the meaning is overwhelming. For the first time, we were not seeing the universe. We were hearing it. Those waves did not travel through air, but through space-time itself, the 4-dimensional fabric of existence. As they passed through Earth, they stretched and squeezed everything by a distance smaller than the width of a proton, and yet our instruments were sensitive enough to detect it. That discovery changed astronomy forever. We had opened a new sense: gravitational hearing, a way to listen to events invisible to light. Since then, dozens of other collisions have been recorded, some between black holes, some between neutron stars, and some between combinations of both. Each produces a slightly different note. Some are low and long, rumbling like the slow strike of a drum. Others are sharp, brief, and bright, the quick clash of heavier masses. Together, they form a cosmic symphony, each tone an event that took place millions or billions of years ago. Every detection begins as data-faint oscillations recorded by mirrors suspended in vacuum. But when converted into sound, the patterns become haunting. They rise and fall like a voice breathing through the universe. They remind us that even the quietest things can carry immense power. If you imagine standing near such a collision, not close enough to be destroyed, but far enough to observe, you would not see fireworks. You would see space itself distort. The light of distant stars would waver as invisible ripples passed through. You might feel time itself stretch and compress, like the tide of an unseen ocean. And if you could somehow translate that movement into sound, it would not be violent, it would be beautiful. A tone, pure and deep, like the ringing of a perfect bell, struck once by eternity. The energy released in a black hole merger is staggering. In a fraction of a second, it can outshine every star in the observable universe combined. But that light is not visible, it exists as gravitational vibration, a pulse of existence moving outward forever. These waves travel unimpeded. They do not fade quickly like light or scatter like sound in air. They pass through everything: stars, gas, entire galaxies barely altered. Each one carries a story. When and where it began, how massive its creators were, how fast they spun, how perfectly they danced before becoming one. And because nothing can stop them, each wave becomes eternal. Long after the galaxies that produced them are gone, their ripples will still cross the cosmos, gently altering space wherever they go. Even now, countless collisions hum through the void, overlapping into a constant background vibration, a faint, cosmic chorus. The Earth itself drifts through that hum every second, and though we cannot feel it, our instruments can. The universe, it turns out, never stops speaking. We are simply learning to listen. There's something deeply human in that discovery. For centuries, we've strained to understand the universe through sight telescopes, cameras, lenses. We've admired its light, but never heard its pulse. Now, finally, we can sense its rhythm. The collision of black holes is not destruction. It is percussion, the universe keeping time. Think of the galaxies as notes, the black holes as drums, the gravitational waves as their resonance. Across billions of light years, the cosmic orchestra plays a piece that began at the dawn of time and will never truly end. Every beat, every hum, every faint vibration that reaches us is proof that existence is active, alive, dynamic. Sometimes, when the waves from multiple collisions overlap, they form harmonies, tiny interference patterns that rise and fall together. Physicists call this the gravitational wave background, the collective music of all black holes merging across history. It is the universe's baseline, humming through every atom of your body right now. If you pause for a moment and breathe slowly, you can almost imagine it a deep, patient vibration beneath everything. It doesn't have a rhythm we can count, yet it feels steady, constant, like a heartbeat stretched across time. That heartbeat has no beginning and no end. It is the rhythm of creation itself, the ongoing sound of gravity shaping reality. So tonight, as you rest, think of that first faint chirp captured by LIGO, the smallest sound ever heard, and yet one that spoke for the entire cosmos. Picture those two black holes colliding far away, their merger echoing through the universe until it found a home in human understanding. The sound you would hear, if you could truly listen, is not destruction. It is a greeting, a soft, ancient voice saying, "I am still here." And as you drift into sleep, remember that you are part of that vibration. The same gravity that moves galaxies moves within you, keeping time with your heartbeat, whispering through your breath. The sound of a collision is not the end of anything. It is the sound of the universe beginning again. The more a black hole feeds, the more it grows. The more it grows, the hungrier it becomes. It is the universe's purest paradox, an eater that creates appetite with every meal, a consumer that expands the very boundaries of its own existence. We like to think of hunger as something that can be satisfied, but for a black hole there is no fullness. Every bit of matter that crosses its horizon adds to its mass, deepens its gravity, and widens its reach. In devouring, it becomes stronger, and in growing stronger, it devours more. It is the quietest of feedback loops, and also the most perfect. To understand this paradox, imagine the event horizon as a living boundary, an invisible skin surrounding the black hole. Each time the black hole absorbs matter or radiation, this skin swells outward, increasing in area. But strangely, its surface temperature drops. The larger a black hole becomes, the colder it gets. A small, stellar mass black hole glows faintly in X-rays. A supermassive one, millions or billions of times larger, is almost perfectly dark. It's as if the universe has built them to cool as they grow, to hide their own power behind stillness. And yet, deep inside, their energy only increases. Their gravity sharpens, their pull extends farther. The contradiction continues, expansion through compression, growth through collapse. When physicists describe black holes, they often use the language of thermodynamics, the science of heat, energy, and entropy. In this analogy, the event horizon is like a container whose surface area represents entropy, the measure of disorder or information. In 1972, Jacob Bekenstein proposed a startling idea that the area of a black hole's horizon corresponds to the amount of information it has absorbed. Every particle that falls in adds a bit to its memory. Though nothing can escape, the black hole somehow remembers what it has consumed, not as matter, but as information encoded on its surface. This concept, later refined by Stephen Hawking, became one of the most profound insights in physics. It led to the idea of the holographic principle, that perhaps everything we experience in 3 dimensions is actually information stored on a 2-dimensional surface, like a cosmic projection. In other words, the universe itself may work like a black hole. Reality, in all its depth, might just be a shadow of data written on the boundary of existence. It's strange, isn't it, that black holes, once thought of as cosmic destroyers, have become teachers of structure and balance. They seem to obey the same laws that govern fire, life, and thought. They consume energy, radiate heat, and maintain equilibrium. Even in their endless appetite, they follow patterns as if creation has built in its own limits. They do not feed recklessly. They feed with precision, and over time, even their consumption gives way to transformation. Because, paradoxically, a black hole's hunger can't last forever. Theoretically, they lose energy through a subtle process known as Hawking radiation, the slow evaporation of black holes over unimaginable timescales. Quantum effects at the event horizon cause pairs of particles to appear briefly in existence. One falls in, while the other escapes, carrying a tiny bit of energy away. This means that even the most massive black holes will one day shrink. It will take longer than the lifetime of all the stars, but the end is certain. The same universe that feeds them also ensures their eventual fading. They are immortal only by human measure, not by cosmic law. The paradox continues at every level. A black hole grows by consuming, but its consumption leads to radiation energy that escapes into the universe. In taking, it gives. In hiding, it reveals. In becoming colder, it maintains the heat of creation elsewhere. Some scientists compare this to ecosystems on Earth, the cycle of decay and growth, of matter moving from one form to another. What one system loses, another gains. A tree falls and feeds the soil. A star collapses and feeds the galaxy. A black hole feeds and, through its radiation and gravity, sustains the balance of the cosmos. The act of devouring becomes an act of giving. From a philosophical view, there is something almost meditative about this. The black hole doesn't chase, doesn't crave, doesn't act with intent. It simply is. Anything that comes too close becomes part of it. Its hunger is not desire. It's gravity's pure expression of being. There's a lesson in that perhaps what we call hunger or need in ourselves is not an enemy, but an engine. The force that draws us to learn, to create, to love. These are our forms of gravity, our ways of expanding the horizon of who we are. To live is to draw experience inward, to let it change you. Every thought, every encounter adds to the surface of your understanding. You too are a kind of event horizon, a consciousness growing by the light it absorbs. Black holes teach us that creation and destruction are two sides of the same law. To consume is to transform. To collapse is to become more whole. Even in the act of falling, there is motion forward deeper into the unity of everything. Perhaps that is why the universe built hunger into its design. Without it, there would be no movement, no story, no stars, no us. And when we gaze into the dark, maybe we recognize something of ourselves there, a quiet center, drawing the world inward, holding it in silence, and radiating it back as warmth. The paradox of consumption is not a tragedy. It is the way the universe breathes. So as you breathe now, feel that rhythm, the soft in and out of life's own gravity. You take in, you let go, you expand, you rest. Somewhere out there, a black hole does the same, unseen but constant, mirroring the pulse of existence itself. You are part of that exchange. You always have been. And as you drift into sleep, remember, nothing in the universe truly disappears. Every bit of light, every piece of matter, every whisper of energy, it all finds a home, even in the heart of darkness. Because in the end, the eater and the eaten are one. For centuries, black holes were imagined as perfect prisons, places from which nothing, not even light, could escape. They were the ultimate endpoints of physics, the final silence after the song of matter. But in the 1,970 seconds, one man, Stephen Hawking, looked deeper into the mathematics of the abyss and found a whisper inside the silence. Black holes, he realized, do not stay silent forever. They glow. It began as a paradox, quantum mechanics. The theory that rules the subatomic world says that even in the emptiest vacuum, particles constantly flicker into and out of existence. These are called quantum fluctuations. Tiny pairs of particles and antiparticles that appear together, live for an instant, and then annihilate each other, leaving behind nothing but potential. Now imagine that happening right at the edge of a black hole, the event horizon, where space and time bend to their breaking point. When a pair of virtual particles appears there, something strange can happen. Gravity can pull them apart before they meet again. One particle falls in, the other escapes. The escaped one becomes real, carrying energy away from the black hole. To an outside observer, the black hole seems to emit faint radiation, a glow from nothingness. This is Hawking radiation. The idea was revolutionary. If black holes can lose energy, then they can lose mass. If they can lose mass, then they can eventually evaporate. A black hole, the universe's symbol of permanence, could one day vanish, completely dissolving into the very light it once refused to release. It's a slow process, almost unimaginably slow. A black hole the size of our sun would take 10 to the power of 67 years to evaporate, far longer than the current age of the universe. But the principle stands. Even darkness leaks light. Even gravity surrenders to entropy. In the end, not even black holes last forever. For Hawking, this realization was both thrilling and terrifying. It suggested that black holes are not the eternal vaults of mystery we once believed them to be. They are, instead, processes, evolving entities that interact with the quantum fabric of the universe. They can grow, shrink, and eventually die. But this discovery also raised a deeper question, one that physicists still wrestle with today. If a black hole evaporates completely, what happens to the information about everything it consumed? Quantum mechanics says information cannot be destroyed. Every particle's history must, in some way, remain traceable. But when something falls into a black hole, it seems to vanish beyond reach. If the hole later evaporates into featureless radiation, where did that information go? This puzzle became known as the black hole information paradox, and it remains one of the most profound mysteries in all of science. Some theorists propose that the information is encoded on the event horizon itself, in a kind of cosmic memory, like ripples on the surface of a pond, recording every pebble that has ever fallen in. Others suggest that when black holes evaporate, the lost information seeps back into the universe as subtle correlations in the escaping radiation. In recent years, hints from string theory and quantum gravity have added new layers to the story. The emerging idea is that the universe is holographic, that the information describing everything inside a region of space can be stored on its boundary. If this is true, then a black hole is not a destroyer at all. It is a projector, translating the contents of reality into patterns of light at its edge. The abyss does not erase, it reinterprets. When you think of Hawking radiation, picture it not as fire or explosion, but as a faint, eternal exhale. Every black hole, from the smallest to the greatest, is breathing out tiny particles of energy, ghostly photons, neutrinos, and other quanta slipping through the cracks of space-time. It is the quietest glow in the universe, yet it ensures that even darkness cannot remain absolute. These photons travel outward forever. Some will wander through intergalactic space, untouched for trillions of years. Some will collide with dust and spark warmth into frozen matter. A few may even pass through your body right now, the faintest echoes of ancient collapse whispering through your atoms. Even when you close your eyes, you live in that faint light. There's something poetic, almost redemptive, in this discovery. For all its devouring power, a black hole still gives something back. It cannot hold everything it takes. It must eventually release. Perhaps the universe itself works by that same rhythm, a balance of taking and giving, absorbing and radiating. We too keep a kind of Hawking radiation of the soul. Small fragments of ourselves, words, kindness, memories escaping into others long after we've turned inward. Nothing is perfectly closed. every silence eventually glows. One day, in the distant future, when the last stars have burned out and galaxies have faded, the only light left in the cosmos will come from evaporating black holes. The universe will be dark, but not entirely dead. Tiny sparks will still flicker in the void, the final size of gravity. Each one will radiate softly, releasing its energy back into space, until nothing remains but warmth and memory. And even then, the quantum foam will still dance, birthing and dissolving particles, a new kind of dawn hidden within the ashes of night. In that far future, when the last black hole fades, the universe will have completed its circle. The light that fell into the abyss will have returned to the stars, scattered and free once more. And perhaps that's the final truth of Hawking radiation, that even in the deepest darkness, the universe finds a way to shine again. So as you breathe now, think of that soft glow. Imagine the darkness around you not as emptiness, but as a place full of quiet radiance, invisible, slow, eternal. Even the most unyielding night carries the promise of light. Close your eyes and let that thought warm you like the faintest ember in infinite space. You are part of the same rhythm, collapse and renewal, silence and song. The black hole breathes, the universe exhales, and the light returns home. There is an old idea, whispered among philosophers and physicists alike, that perhaps the universe created consciousness so it could look at itself. That matter, when arranged in the right way, begins to wonder where it came from. That stars burn and black holes feed, and galaxies spin not just to exist, but to be seen. And if that is true, then black holes, those dark mirrors of existence, are the eyes through which the universe examines its own depth. Think about it. Black holes are the ultimate recorders. Every piece of matter that falls into one leaves an imprint, a trace of its history, encoded in the surface of the event horizon. Information, though hidden, is never lost. It's preserved in the wrinkles of space-time itself. So when we study black holes, when we decode their gravitational waves or capture their silhouettes through telescopes, we are watching the universe remember. Every photon we detect, every echo of a collision, is a piece of cosmic autobiography, the story of how the universe consumes, transforms, and understands itself. Even now, as you sit beneath the quiet sky, your eyes catching ancient light from distant stars, you are part of that same self-awareness. The atoms in your body once drifted through the accretion disks of dying suns, through the dust of galaxies that black holes help to shape. You are the cosmos, observing its own reflection. Consciousness, then, is not an accident of biology. It may be the inevitable result of a universe that cannot bear to be blind. Just as a black hole bends light inward, consciousness bends reality inward, turning experience into reflection, chaos into meaning. Every act of curiosity, every time you look at the night sky and wonder why it shines, is the universe taking a long, slow breath of recognition. Astronomers often say that black holes reveal the limits of what can be known. But perhaps they do the opposite. Perhaps they remind us that knowing itself is part of the cosmic process, that discovery is not separate from creation, but an extension of it. When you peer into a black hole, it peers back. The same mathematics that describe black holes also describe the human mind in metaphor. There is the event horizon of perception, the boundary beyond which thoughts cannot escape into words. There is the singularity of emotion, the point where experience becomes so intense it folds in on itself, undefinable but real. There is the accretion disk of memory, the swirling ring of moments orbiting the center of who you are, glowing with the heat of everything you've lived. We too feed on light, the light of ideas, of experiences, of each other. We too transform what we take in and radiate it outward in softer, gentler forms. In this sense, every mind is a small black hole, turning chaos into coherence, silence into awareness. When Stephen Hawking wrote that black holes might eventually evaporate, he ended his paper with a simple phrase, "Black holes aren't as black as they are painted." He meant it scientifically that they emit radiation, but it also holds a deeper meaning. Darkness is never pure absence. Even the void hums with thought. Even silence contains a trace of understanding. The universe is not indifferent. It is contemplative. Picture this. Somewhere far away, a supermassive black hole turns slowly in the heart of a galaxy. Around it, stars orbit like golden fireflies, and clouds of plasma flare in rhythmic pulses. To most of the cosmos, it's just another gravitational engine. But perhaps, in a way too subtle for us to measure, that black hole knows it's being seen. Maybe awareness, in some primal form, stretches across everything from atoms to galaxies, like a low vibration of being. Maybe the whole cosmos participates in the act of observation, and we, as conscious beings, are simply one of its many instruments. If so, then every time we look through a telescope or dream about distant worlds, the universe itself is dreaming through us. It is a beautiful symmetry. Black holes pull information inward, while human minds pull meaning outward. One shapes the physical, the other the perceptual. Together, they complete the circle of knowing. That might explain why the image of a black hole affects us so deeply. It's not just science, it's recognition. When we look into that glowing ring of fire around darkness, we are seeing the geometry of awareness, the structure of mystery itself. Something in us recognizes the pattern. The center we cannot see, surrounded by light we can. It's the same pattern that defines every thought, every feeling, every act of wonder. The unknown wrapped in the known, the question surrounded by the glow of trying to understand. As you listen now, you are participating in the oldest act of the cosmos, attention. The stars give off their light. Black holes bend that light into new forms. Your eyes and mind receive it, turning photons into meaning, silence into story. It is a collaboration, an endless feedback loop of perception. The universe speaks through light, and consciousness answers through awareness. Maybe that's what existence really is, the dialogue between gravity and thought, between what falls inward and what looks outward. So close your eyes for a moment. Feel the weight of your body, the pull of the earth beneath you, that gentle gravity that binds you to this spinning world. Feel your thoughts orbiting slowly around the quiet center inside your mind. You are not separate from the cosmos. You are its reflection, its witness, its question. The same forces that turn galaxies also turn your breath. The same gravity that holds black holes together holds the molecules of your bones. The universe is watching itself through you, and you are watching it right back. And somewhere, deep in the heart of that reciprocity, meaning arises soft, mysterious, and endless. When the feeding ends, the black hole rests. The glowing ring of plasma cools. The jets fade into silence, and the last shreds of light spiral inward, disappearing one by one into the waiting dark. What was once a roaring storm of energy becomes still again, a single point of gravity sleeping at the center of its galaxy. The universe has no rush. It breathes in epochs, not moments. And so the black hole sleeps, perhaps for millions of years, until another star wanders near, until another tide begins. Between those awakenings, there is peace, a kind of cosmic exhalation. If you could float nearby, you would see the space around it quiet and calm. The radiation that once blazed from the accretion disk has thinned into a soft haze. Dust drifts through the void like slow snow. The gravity is still there, immense, patient, but the violence is gone. What remains is structure, the graceful arcs of stars bound in steady orbit, the dim glow of gas clouds reflecting the memory of old light. The black hole does not vanish. It endures, invisible but present, the spine of its galaxy's design. The stars will rise and fall around it for billions of years, and it will remain not as a destroyer, but as balance embodied. When astronomers study these sleeping giants, they find a strange serenity in them. A dormant black hole emits almost no light. It neither consumes nor resists. It simply waits. Time seems to flow differently, near it not in the frantic rush of creation, but in long, steady pulses. The galaxy moves, but its center does not. There is something deeply meditative about that image stillness at the heart of motion, silence beneath the noise of light. Perhaps every galaxy needs such a center, a place where time slows, where energy gathers, where everything can find its axis. The same may be true for us. Within each of us lies a quiet gravity, a stillness that holds the fragments of our experience together. Life swirls around it, joys, fears, memories, but the center remains calm. Sometimes we forget that the universe, for all its grandeur, is mostly made of silence. The bright explosions of stars, the brief lives of galaxies, these are moments, not constants. The background is stillness. In the same way, the noise of our daily existence, the motion, the striving, are only temporary bursts of brightness in a larger rhythm of rest. The cosmos reminds us that even the most powerful forces must pause, that every flame eventually settles into ash, and every hunger into peace. The quiet after the feast is not absence, it is fulfillment. Over time, the sleeping black hole gathers a faint halo of starlight. Stars too far to be devoured still feel its pull. Their orbits trace invisible patterns around it, slow and steady. Some drift closer and are slingshotted away, gaining speed and freedom. Others spiral inward, so gradually that their fall takes longer than civilizations last. The black hole influences everything, yet never boasts. It shapes without showing. It teaches by presence alone. When we look at the great spiral galaxies through telescopes, the elegant swirls of gold and sapphire light, we are seeing the handwriting of black holes. They are the authors of symmetry. They're gravity sketching patterns that stars merely illuminate. And when those same galaxies fade, the black holes will still remain, their invisible mass holding the memory of their form. Eventually, even these black holes will fade. One by one, through the faint trickle of Hawking radiation, they will release their stored energy back into the universe. It will take unimaginable time, longer than the life of every star that ever existed. But the process is patient. The cosmos can afford patience. When that era comes, the universe will be quiet again. The stars will be gone, the galaxies dissolved, the last black holes glowing softly like dying embers. The night will not be dark, but warm, filled with the final radiation of everything that has ever been. That will be the universe's twilight, the long, gentle sigh after creation's song. But even that is not truly an ending. The particles escaping from those fading black holes will drift, meet, and perhaps begin something new. The same laws that created the first stars will remain written in the background fabric of reality. From the ashes of the old, another dawn may rise, not in our sense of time, but in the universe's. Nothing truly ends, it only rests. So tonight, as you lie beneath the same stars that orbit a sleeping black hole at the galaxy's center, remember that peace is not the absence of motion, it is the harmony of it. The universe is not still because it is empty, it is still because it has found its rhythm. You are part of that rhythm. Your breath is the echo of gravity. Your silence is the echo of the cosmos between its feasts. In every cycle, birth, growth, collapse, rest, there is meaning. The black hole's quiet is the same quiet that hums between your thoughts when the world slows down, and you simply are. That quiet is the shape of eternity. And so the story ends where it began. In silence, in gravity, in wonder, the hungry hearts of the cosmos have eaten, shone, and slept. Their light has crossed time to reach you, a traveler listening in the dark. Close your eyes. Let the noise fade. The universe is at peace, and for this moment, so are you. Good night.